So let us see another thermoplastic process in which blow molding process is there by using a thermoplastic material. So it is a molding process in which air pressure is used to spread the plastic into the mold cavity. So it is used to make hollow seamless parts which is in thin wall, which is having a thin walls like bottles, container. Here you can see in the application containers etc. from thermoplastic polymers. So blow molding is preferred in two steps. First, fabrication of this parison, and later on this parison will be used to blow into the cavity, and after blowing into the cavity you will get final shape of your component. So here you can see the different stages. Initially this blue part will be called as an. So the blow molding consists of an extrusion of heated tubular plastic piece which is called as an parison. So here you can see the figure uh, which is transferred to the two-piece mold. So the parison is gripped between two piece. This is two-piece mold, and its bottom end is sealed. So then air is injected into the parison to force the plastic against the wall of the water-cooled mold. The pressure air is about around 400 to 800 kilopascal, and as the form component cools, the mold is opened and part is removed. So this operation is similar to that use of forming bottles in glass industries. So polyethylene or polypropylene and cellulose acetate are some of the plastic that can be formed by blow molding. So let us see the advantages. It is having a low tooling cost, fast production rates, ability to mold complex parts with a uniform thickness, little scrap generated, large hollow shape can be produced, produced parts can be recycled. Then disadvantages, limited to hollow parts, thickness part can be manufactured, that is thick part can be manufactured. Then application, bottles in different shape and size, jars, containers, fluid oil tanks, mugs and toys etc. These are the application of blow molding process. So another is an thermoforming process which can be classified as an vacuum thermoforming and pressure thermoforming. So it is a series of process for forming thermoplastic sheets or film over a mold with the application of heat and pressure. So it is used in packaging of consumer products and fabricated large parts like bathtubs or internal doors, liners, etc. So it consists of two main steps: heating and forming. So heating is carried out by radiant electric heaters and located on one of or both sides of the starting plastic sheets. And time of heating depends on the type of polymer, thickness and color. And the method of which used to carry out this operation are classified as an vacuum thermoforming and pressure thermoforming. So the figure which is seen on a screen, which is called as an vacuum thermoforming. So here it employs a clamp to grip the plastic sheet having thickness of about 0.125 to 3.2 mm around its circumference. This one, a heater is used to bring the polymer to a temperature about 55 degrees Celsius to 90 degrees Celsius until it begins to sag. So through the small holes in a die, vacuum is applied and the sagging plastic sheet is thus pulled tightly against the mold, acquiring the mold shape. So as the mold is cool, the polymer is sealed and stiffened by die contact. So it shows that instead of vacuum, sometimes hot air is used to drive the plastic sheet into the female mold cavity, and finally you will get this kind of an shape which is towards the bottom side. So even if you want some complex shape, you can go for this kind of an arrangement. And if you have seen the mask of Hanumanji or Ramji. In I think what we can call in toys, you can see that there are the mask of different gods like Hanuman. Those all can be made by vacuum process. Thermoforming process. Let us see another, that is an pressure thermoforming process. In pressure thermoforming process, it involves positive pressure as there will be no vacuum, and it forces the heated plastic into the mold cavity, and it is called blow forming. So the main advantage of pressure forming over vacuum forming is that higher pressures can be developed on the component, and the process sequence is similar to vacuum forming. The difference being that the sheet is pressurized from above into the mold cavity. So vent holes are provided to exhaust the trapped air at this side, and the forming portion of sequence is in this way. So initially it will apply a pressurized air from the top, and later on whatever the air will be present in this cavity will be drain out, and it will get its final shape by applying an external pressure. So this is called as pressure thermoforming. So advantages: extremely adaptive to design requirement, rapid prototype development, low initial setup cost, low production cost, and less thermal stresses than injection molding and compression molding, good dimensional stability. Disadvantages: poor surface finish, parts may have non-uniform wall thickness, all parts need to be trimmed, ribs and bosses cannot be molded easily. So if there are some critical parts or shape of having some particular thickness will be not can be used under for this condition. Very thick plastic sheets can be formed, and so this will not come in actually disadvantages. That is, very thick plastic sheets can be formed. So this will be in advantages. An application: food packaging, automotive parts, trays, building products, aircrafts, windscreen. So if you have seen the bottle packing of 1 liter or in hot season, those all Sprite thumbs up bottles which comes in quantity, those all are packed with this all uh, pressurized thermoforming process. You might have seen that plastic is covered with on some quantity of bottles. So those are done by vacuum thermoforming processes. So next lecture we'll see extrusion. So thank you.